Hey guys, so we're going to do this related rates in kind of like pieces. So the first thing we're going to do is the first three questions, and then we'll do the others, just so it's not like one super long video. So when I read this, I see that air is being pumped into a spherical balloon so that its volume increases at a rate. So this is dV dt. And we want to know how fast is the radius of the balloon increasing. So this is going to be dr dt. So we have a couple pieces of information, and we were told the volume of a sphere is 4/3 pi r cubed. So let's take the derivative of that. So the derivative, dv dt, is equal to, well, 3 times 4/3 is 4 pi r squared dr dt. If the diameter is 50, then the radius is going to be 25. And let's just plug everything in. So dv dt is 100. And then we have 4 pi r squared times dr dt. So this is 25, and we're looking for dr dt. Now we could square that out and look at that math, but if we look at this, dr dt is going to be 100 divided by 4 times pi times 25 squared. 100 divided by 4 rather is 25. And this 25 is going to cancel with one of these 25s, so we're going to have 1 over 25 pi. I think that we've gotten pretty good at these ladder problems. And so this ladder has a length of 10. Let's call this x and call this y. The relationship that I have, x squared plus y squared is equal to, well, 10 squared is 100. If we take the derivative of that, 2x dx dt plus 2y dy dt is equal to 0. The bottom of the ladder is going to be 6 feet away from the wall, and this is a Pythagorean triple, so it's 6, 8, 10. The bottom of the ladder, dx dt, is sliding away at a rate of 1 feet per second, and we're looking for how fast it's sliding down. So we're looking for dy dt. These 2's are going to cancel, so let's put in 6 times 1 plus 8 times what we're looking for is equal to 0. 8 dy dt is equal to -6, because if we subtract 6 over from both sides, that's a terrible 6. And then we divide both sides by 8. Then -6 over 8 reduces to -3/4. It's not overly apparent what the relationship is here, but if I have an angle and I have the opposite side and we know the length of the hypotenuse, then we can relate them and say that the sine of this angle is equal to the opposite over the hypotenuse. And then if we want to find like the rates of which these things are changing, let's take the derivative of both sides. So the derivative of sine is cosine d theta dt is equal to 1/5 dx dt. X is equal to 4, which would make this side length 3. Now that's going to be important when we go to find cosine. This should be a theta here, sorry. So the cosine of this angle is the adjacent over the hypotenuse. So the adjacent, 3 over 5 times d theta dt, which was given to us in the problem, 2 is equal to 1/5 dx dt. Let's multiply everything by 5, and then that's going to cancel, so we're going to have 6 feet per hour. Alright, the next video will have questions 4 and 5.